This video is the first piece of course content for week 2 of the course Quantitative Analysis, Applied Inferential Statistics. I want to accomplish 3 things with this video. First, I want to introduce you to ggplot2, the cutting-edge tool for visualizing data that is part of the tidyverse. Second, I want to introduce you to geometric objects, different ways we can manipulate various types of data for visualization purposes. And finally, I want to give you a quick tour of RStudio's plots window. To start, I want to talk a bit about the ggplot function. It's a part of ggplot2, a package that is a core piece of the tidyverse. It's automatically loaded when you load the tidyverse package, and it is one of the best ways to produce plots that's out there. R is attracting users in part because they can use ggplot2 for visualizing their data. At its most basic, the ggplot function pulls data from a data frame for plotting. It does this by assigning data to the ggplot function. However, you cannot stop here. This will only produce an empty plot. Rather, the ggplot2 function must be paired with a geometric object, or geom for short. We do this with a plus sign that combines the initial ggplot2 function with a variety of possible geoms. For instance, we could visualize a continuous variable in the miles per gallon data set that comes built in with ggplot2. For instance, we could pick highway miles per gallon, which is a continuous variable, and we could visualize it using a histogram, which is a common way to visualize continuous variables. To do this, we use the geom histogram function to produce our plot. And we're going to map an aesthetic to it. Now, aesthetics may not be something you're familiar with. Aesthetics are instructions to R that specify how specific variables are associated with particular visual properties. We'll specify these within the geom for now by setting mapping equal to an aesthetic that contains the variable name we wish to plot. When we execute that pair of functions, we get this nice looking output. It isn't quite production ready. It's missing some key features like a title and some additional information about what the variables actually mean. But for what we call exploratory data analysis, which is the act of plotting your data to understand variation within it, the relationship between variables, this plot will do nicely. We can see that there are 2 clusters of vehicles that are right around 16 miles per gallon in terms of their highway fuel efficiency, and again around 26 and 28 miles per gallon or so. There are a few vehicles with very poor gas mileage, and a few with very good gas mileage, that's over 40 miles per gallon. Aside from histograms, there's a wide variety of geoms to choose from that are built into ggplot2, and even more that are available from add-on packages that you can download from CRAN. I want to give you a taste of just a few of them here. We'll talk more about their statistical properties in the coming weeks, but for now I want to focus on some basic aspects of the code and the plot's design. Line plots are an alternative way to plot continuous data. They show the density of observations for a given value of a continuous variable. We use the freq-poly geom to produce them. All that changes with this plot from our initial histogram is the geom itself. The data and the aesthetic mapping remain the same. And here's what the output of that pair of functions looks like. We can see the same peaks and valleys in the data that we observed in the histogram, only visualized just a little bit differently. If we have a single binary, categorical, or ordinal variable, which I'll refer to collectively as a discrete variable here, since that's how they're referenced in ggplot2's documentation, we can plot these data using a bar plot. This uses the bar geom. If we plot the types of cars, SUVs, compacts, pickups, and so on, we can see the number of cars that fall into each class. Here's the plot that code produces. With the bar plot, we can see that SUVs are the most common vehicle in this dataset, followed by compact vehicles. There are relatively few 2-seaters, small sports cars, and just a few more minivans in the dataset. A key part of exploratory data analysis is looking at the relationships among variables in your data, and ggplot2 gives us a variety of ways to compare 2 variables at once. One such tool is the scatterplot geom. You'll notice here that the aesthetic itself is slightly different. We specify two variables, an x variable and a y variable, and separate them with a comma. For instance, we can look at the relationship between the size of an engine, or its displacement, and the vehicle's highway miles per gallon. We specify displacement as the x variable and highway fuel efficiency as the y variable. With scatter plots, we typically use two continuous variables. When we produce that plot, we can see that there is a clear pattern in the data. Cars with smaller engines are generally more fuel efficient than those with larger engines. Each point represents a single vehicle positioned by both its displacement and its fuel efficiency. An alternative way to visualize the same pattern is with a smooth line. This gives us what we often refer to as the best fit line between two variables, a sort of summary of all the data points we saw in the scatter plot. We use the smooth geome to accomplish this, along with the same aesthetic mapping as we used previously. Like the scatter plot, this geome is best for two continuous variables. When we use this geome with our example data, we can see the same pattern I described with the scatter plot, but perhaps a little more clearly. There is an interesting uptick in fuel efficiency for cars that have particularly high displacements, something that was not quite as apparent in the scatter plot, and something that might be worthy of further exploration later. Finally, if we want to explore variation in a continuous variable by its relationship with a discrete variable, we can create a box plot. We'll use the box plot geome, which is one way to identify outliers in our data, observations that are either far larger or far smaller than the bulk of the observations in that category. We'll use the class variable again, in part because it is a reasonable assumption that compact cars as a group have a different fuel efficiency than SUVs as a group. When we execute those functions, we see the following plot. We can see that compact cars have a generally higher level of fuel efficiency than SUVs based on where the box and the horizontal line in its middle are placed. The dots that you see on some of the boxes are outliers, extreme values within each category. Now that we have a few geometric tools at our disposal, we can put them to use in RStudio. We'll start by loading the tidyverse package as we have before in a new project for week 2. To create the histogram we discussed at the beginning of this lecture, we start with the ggplot function and set the data equal to the miles per gallon data frame that is built into ggplot2. Once we've specified that ggplot function, we'll add a plus sign and hit return. Note how R does not execute the function at this point. Instead, it waits for us to add more detail. We'll use the histogram geome and an aesthetic mapping, in this case the highway miles per gallon variable. Now we'll hit return, and the plot will be produced in the Plots tab. The Plots tab is located in the lower right-hand side of your screen. It has a number of tools for interacting with your plots. We can use the zoom tool to expand the plot, like so. And there are also export tools here to save the plot as an image file or a PDF.